Alright, for this one we have exponential and logarithmic functions. For number 1, suppose you invest $1,500 at an interest rate of 2%, compounded monthly for 15 years. How much money will you have in the account after 15 years? So we're using this compound interest formula here, where A is our total amount, that's what we're trying to solve for here, is equal to P is our principal, the amount that was invested here, which was the $1,500, times, in parentheses, 1 plus R, which is our interest rate. But we need to convert that interest rate of 2% to a decimal. So as a decimal, that would be 0.02. Do not forget to do that, otherwise your answer is going to be a lot different than it should be. Divided by n, which is the number of times it's compounded per year. So in this case, it is compounded monthly. Monthly, there are 12 months in a year, so that means n is equal to 12 here. So we'll plug in 12 for our n, and then close the parentheses, and then the n times t is in the exponent together. Both of those are being multiplied together in the exponent. So here we'd have the 12 times, and then t is our time, which is the 15 years. And time always has to be in years. So if it's in months or days or something else, you will need to convert that to years before solving the problem. So here, to help avoid any mistakes in your calculator, it might be helpful to calculate that exponent part first. So we'd have that 1,500 plus that 0.02 divided by the 12. And then in the exponent, if you do the 12 times 15, you should get 180. And then go through and multiply that all together. Some of your calculators, you might still have to split up some of those order of operations yourself. Others of you may be able to do it all at once. Just depends on how your calculator is programmed once again. So here you should get $2,024.28. And that is approximately what you should expect in that account after 15 years if it is compounded monthly at a rate of 2%. And make sure, don't round your answer until that very last step. Otherwise your answer is going to be different. So make sure to round to the very last step. So if you need to do extra steps in there, make sure to write out all the digits until the very end. For number 2, suppose you now invest some amount P into an account at a rate of 3.5%. This time we're compounding it continuously. We want to know how long will it take for the amount to double. So if we want that amount to double, that total amount, that means we'd have 2p is equal to, and then p, because p is the amount that was invested in this case, and we did the 2p because that's 2 times that amount, because we're doubling it. And then we have our e, which remember is a button on your calculator. It might be as an e or it might be as an e to the x, depending on how your calculator is programmed. And then in the exponent here, we're going to have our interest rate r, which once again, make sure to rewrite that rather as a decimal. So we'd have 0.035 as a decimal there. So we'd have our 0.035. And then times our time t, which is what we're trying to solve for, because we're trying to figure out how long it will take for it to double, which is our time. So, like normal, we want to try and get our t, our time that we're trying to solve for, by itself. So we can divide both sides by p, which in this case will cancel out p on both sides of the equation, which is all right here because we're trying to solve for t instead. So we'd have 2 is equal to e, and then your 0.035 t. Or if you want, you could start at this step if you know you're trying to double it. And then whenever you have that e function, you have to do the ln of both sides to get that ln of e to cancel out with that e there. So ln and e are inverses of each other. They will cancel each other out, just like multiplication and division cancel each other out. So here on the right hand side, we now have 0.035t is equal to that ln of 2. And I would just wait to plug that into your calculator until that very last step. So once again, we want to wait to round until the last step here. That way we all get the same answer. So then divide by that 0.035 on both sides to finish getting t by itself here. So then once we divide that out, we should get about 19.8, and our time is always in terms of years in these formulas, 19.8 years. So make sure, once again, anytime you're dealing with a word problem, that you are including those units as part of your answer, because it could vary depending on the problem of what type of units you would have. So once again, make sure, like normal, if you have questions on any of this stuff, make sure to ask.